times V1 equals, on this side, it's going to be T1, and then P2, V2. P2, V2. All right, now I want to get this term by itself, T2 by itself, so I'm going to divide this whole side by P1 and V1. So it's going to look something like this. So I'm going to divide both sides by P1, V1. And this side is going to be divided by P1, V1. Yeah, I'm just double checking myself right here. Yeah, P1, V1. Fantastic. So what this does now, this is crossed off, and this nothing crosses off on this side, but we're going to have T2 by itself. Okay, this is a little bit of an awkward algebraic manipulation right here. That's why I chose to do it, because you can get kind of lost in multiplying and dividing at this point. But all it is algebra. So this is T2 equals P2 times V2 times T1 times T1 divided by P1. Oh, I can't get any more space down. P1 and V1. It's a P. All right, so now T2 is by itself. Fantastic. All I've got to do now is I've just got to plug in the numbers. P2 is going to be 1.7. V2 is going to be 1.9. T1 is going to be 245 Kelvin. And V1 and P1, well, we can see what those are right there. V1 is 2.4 and P1 is 1.2. When you plug all of those numbers in, okay, if you plug all of those numbers in, you're going to get the number 200. You'll see T2 is going to be, all right, in green, T2 is going to be, if you plug all those numbers in correctly, 274.77 degrees Kelvin. Now, the question, if you look at the question, it says 1.2, and you can look at all these values over here too. There's 1.2 pascals, and 1.7 pascals, 1.9, 245, 2.4. Those numbers right there, those are important because they give you the number of sig figs you need to round to. So the lowest amount of sig figs is the number we need to round to. So it looks like 2 sig figs, 2 sig figs, 2 sig figs. So we need to round this number to 2 sig figs. To round this number to 2 sig figs, here's what you do. You count the first sig fig, then the second sig fig, and then you go shunk, and you cut off the rest of the number, and you say to yourself, do I need to round this number, this 7 here, do we need to round that number up, or does it stay the same? And the 4 does not make it round up. A 5 would make it round up. So we're left with 270 degrees Kelvin. That's our value for T2, and that would be the correct value on the test. Now the test takes into account sig figs, so if you get the sig fig wrong, you get the entire problem wrong, which is really high stakes sig figs. It's crazy. But you need to abide by the sig fig rules. So make sure you know how to round the correct number of sig figs. It's very, very important for this test. Okay? So this is an example of a problem where you're using this equation right here. That was one of your questions, Lily Francis. Now I'm going to do a different question that's more related to a regular ideal gas law question. Okay? So I'm going to do number 3, practice problem number 3. Yeah. Practice problem number 3. Yeah, that one works. Great. Okay, I was just making sure that I could do that right now. So take out your practice problem number 3 and see if you can follow along with me here. Let me get a brand new screen. Right. Okay. A sample of argon gas occupies 5.62 liters. And it says STP. What does STP mean? Oh, I forgot that I need to tell you guys about that. Okay. STP. That explains a lot. Oh, now I understand why you guys might have gotten those problems wrong. STP. Did I go through what STP was before? STP. Standard temperature and pressure. Yes, I do. This means that the gas, it's in our notes. This means the gas is 273 degrees Kelvin and 1 atmosphere. 1 atmosphere is 1.013 times 10 to the 5th pascals. So that's a little bit awkward, but that's what it is. Okay, so we know that this thing has standard temperature and pressure. So the temperature, we know of this gas. The temperature, we know it already. The temperature is going to be 273 degrees Kelvin, and the pressure is going to be 1.013 times 10 to the 5th pascals. We know that already, and it occupies 56.2 liters. The volume is 56.2 liters, and that's not a good unit. So we're going to practice conversions right now. A conversion factor is given to you. It says 1 meter cubed equals 1,000 liters. So this will be a very easy conversion really quickly. Right. So let's convert it. To do this problem, it says determine the number of moles of argon in the sample. So you don't know the number of moles. So N is a thing that you need to figure out. But it's almost like a knee-jerk reaction. A knee-jerk reaction. It's almost just like instinctual. When I see a unit that I don't like and I need to convert it, I just want to convert it right away without doing anything else. So I'm going to do that right now. Before we even start this problem, I just want to convert this unit from liters into meters cubed, because meters cubed is what we need to solve this problem. Okay? So, and I know that because that's a standard unit that we need to change all of our volume into. So let's change these liters into meters cubed. All right. So we start off with 56.2 liters. We're going to multiply by something to get what we want, which is meters cubed. So how am I going to rearrange this? Well, I want to put the unit that I'm converting out of on the bottom so I can cancel out the liters. So I'm going to say 1,000 liters on the bottom and then 1 meter cubed on top. The liters will cross off, and we're going to be left with 0.0562 meters cubed. Okay, that's going to be our volume. So I'm just going to erase the 56.2 liters right now. I'm going to say, right, I don't even want to look at that anymore, because now my volume that I'm going to use is in meters cubed, which is the correct unit that I use when I use the PV equals nRT, or the pervnert equation. Right. That's the volume. The only other thing that's missing right now is our R, the constant that's always given to you, so you don't need to memorize this. Don't worry about it. It's just a constant that you need to put in. It's 8.314 joules per degree Kelvin mole. Okay? Right. So, the question asks you for the number of moles, and you're given all this other information. Now, you could start off, if you want to, you could say, oh, okay, well, maybe this is the equation I use. Oh, okay, maybe this is it. Oh, I don't know. Let's see. Well, in this equation, you would go hit a dead end right away, because there's no moles in this equation. Nothing like that. So there's no way you can answer this question. It doesn't even talk about moles. So this is not the right equation. The only other equation we have is PV equals nRT, or the pervnert equation, where we're trying to find N, which is the number of moles. The question asks you for the number of moles. What's the number of moles, given all the other information? Everything else is given. Okay, so let's solve for N first, and then plug in our numbers, and we'll get our right answer. So it's a pretty easy equation to manipulate now. So we're going to take the PV, and we're going to divide both sides by RT. So when I do that, I'm going to get this. So this is assuming you do this step. So divide both sides by RT. Divide this side by RT. These will cross off, and you'll get PV over RT. And that's your number of moles. So now all you need to do is plug in these numbers. I could plug those numbers, I could write these numbers out right now if you want me to. Yeah, what the heck. I'll do it. Times 10 to the 5th. This is pascals. Times the volume, which is 0.0562 meters cubed. Our units are good. Rydberg constant is 8.314 joules per degree Kelvin mole. And our temperature is 273 degrees Kelvin. All right. This will get you the number of moles. Doesn't matter what gas we're talking about. It's just in the problem it says argon gas. Well, that's great. It doesn't really matter what this gas is made of right now. We're just talking about the number of those gas particles. So if you put all these numbers in your calculator correctly and you hit the enter button, you're going to come up with this number 2.51 moles. Okay, and this will be of argon gas. This is with 3 sig figs here. I'm going to double check right here to see what the question was, or what the answer was without it being rounded, so I can round it with you. So I'm going to put this in my calculator right now. Fifth. Take this times 0.0562. Take that whole thing. Okay. 4 times 273. All right. Okay. So without it being rounded, this is what I got. And make sure you get this. 2.50826 something. Okay. So I rounded this to 3 sig figs because it gave us the unit 56.2 liters right, well, in our volume before I crossed it off. There's 3 sig figs there. And that was the smallest number of sig figs. So I went 1, 2, 3 sig figs over, and I said shrink, and I cut it off right there. And that 8 means that I round this 0 up to 1. So my final answer is 2.51 moles of argon gas. Make sure that you get the rounding correct, because those rounding errors really, really penalize you in these kinds of tests, since if you get that wrong, you won't get the problem right. Okay, so practice your sig figs, practice your conversions, practice your algebra around the ideal gas laws, so you can manipulate those equations correctly. Practice setting up your problems where you write out what's given to you first, what you need, and what equation might work. Then manipulate that equation, plug in these numbers, and you should get the right answer. Okay? So a couple things that might go wrong in these equations is that you might not realize that you need to convert some of the units. Like in this case, right here, this unit needs to be meters cubed. If it's not meters cubed, you need to find a way to get that measurement into meters cubed. If this is not in pascals, you got to get it in pascals somehow, and you'll have a conversion factor for that. If this is not in Kelvin, well, I think all of them are actually in Kelvin. If they're not in Kelvin, I don't think I give you this, but I will tell you what it is. To get into something into degrees Kelvin, all you do is you take whatever degrees Celsius and you add 273 degrees to it. So if you have, let's say, something that is 15 degrees Celsius, and you want to know, well, what is that in Kelvin? Well, you just take that plus 273. Okay? And that will get you what your answer is in Kelvin. So in this case, it'll be 288 degrees Kelvin. That's what 15 degrees Celsius is. Okay? Okay. I hope this makes sense. Please let me know if you have any questions. Good luck studying. Again, look over your conversions. You'll do fine. There's just a few questions here, and make sure you do yourself a service and review rounding with sig figs. Believe me, that will help you a lot, not just in this test, but in future tests. So, good luck, and let me know if you have any questions. Bye.